Ladies and gentlemen, we already have a video uploaded on the odd ones. We're going to be doing the even ones on this one, okay? Let's first understand that not all these questions, there's only going to be 20 questions on the test. So as I explained on the previous video, like this one right here, numbers 5, 6, there's only going to be one of these. There's only going to be one of these. There's only going to be one of these 3. So we're definitely chopping it down. This practice test is way too long to have as an actual test, all right? So it's going to be only 20 questions. There's going to be a lot of deletion, right? So let's move to the even ones since we did the odd ones on the previous video. Right here, if you type in the square root of 12 onto your Casio calculator, it will simplify it for you. And if you don't have a calculator, you could just rewrite it as 4 times 3 and then split the root. So you'll end up with 2 square root of 3. Now the first square root of 3 up here, we're not going to mess with it. We're just going to bring it down. And you're adding, and over here we're adding also, and let's do the same for the second one. 27, that could be rewritten as 9 times 3, and when you split it, it becomes 3 square root of 3. So the fact of the matter is we have 1 of these square roots of 3's plus 2 of those square roots of 3's plus 3 of those square roots of 3's. We're going to have a total of 6 of those square roots of 3's. But then again, since there's no variables in here, I guess you could actually type this whole thing into your Casio calculator and it'll do it for you and you'll get the answer. Okay. But I just explained how you get the answer without the calculator. Let's jump to number 4. Anytime you have any type of root, whether it's a square root, fourth root, third root, split up the root and try to do the math. So we're going to have the third root of negative 27, the third root of d squared, the third root of f to the 8. Now, the third root of negative 27, that's actually negative 3. Because negative 3 times negative 3 is positive 9 times negative 3 will get you that negative 27 on the inside. So that's a nice, beautiful integer, negative 3. Now, the third root of d squared, you can't really do that. Even if you thought changing it to a power over root, you'd end up with d to the 2/3 power, and you can't reduce that, you can't divide that, so there's really no point in changing it to d to the 2/3 power, unless I specifically tell you rewrite it in exponential form, then you would change it. Now this last one, f to the 8th, there's a couple of ways of rewriting this one, simplifying this one. You could change it to a rational exponent. So this is what I'm going to do over here on the side. I want to go up here and rewrite it as a f to the 8 over 3, power over root. And 8/3, 8 divided by 3, that'll go in 2 times with the remainder of 2. So what we would do is rewrite it as f to the 2 and 2/3 power. I hope everybody's with me. That's really ugly fraction right there. 2/3 power. 2 and 2/3 power. And then we're going to use rule 1 of exponents to split the base f into 2. Put an f there and an f there. And the power 2 is going to go on the first f, and the power of 2/3 goes on the second f, power of 2/3. So why did I do that? Because I now have a nice beautiful f squared. Kind of like I have a nice beautiful negative 3, I could put that beautiful negative 3 times the f squared together. Now this guy right here is still the third root of f squared. And since we are dealing with the radical, let's change it back to radical form, the third root of f squared. So we have the third root of f squared. And what do we have left? We have this third root of d squared with the third root of f squared. So let's put those together and write them as the third root of d squared f squared. And that is your final answer for number 4. Could it have been done differently? Yes, absolutely. Especially this last part. Let's say you get confused by changing it to a power over root and then reducing and then splitting. That might be confusing to some people. So let me give you an alternate route. You could have, if you wanted to, changed the third root of f to the 8. This guy right here, you could have thought, okay, I want this to be divisible by this root 3. It'd be nice if it were a 9, but it's not. So what I could do is rewrite it with multiplication to get something that's divisible by 3, kind of like a f to the 6th but then I'd still have the f squared. Does that make sense? This is just another way of doing it. It's totally up to you if you want to go with the first way I explained it or this other way I'm explaining it. Now you could actually split the root, and when you did do the third root of f to the 6th, what do we get as a power over root? Anybody? The third root of f to the 6th, power over root, what do we get? F squared. So this becomes f squared, and this one stays the third root of f. It's the same exact thing. We got the f squared, and we got the third root of f to the second power, right? So you could do it that way as well. It's totally up to you. Let's jump to number 6. So that would be this one right here, and we want to change the radical to a rational exponent. So instead of the radical 9, the root 9, we're going to have x to the rational exponent power. We're going to have a fraction as an exponent, and it's always going to be power over root. So the power 7 is going to go over the root 9. There's your answer. Now, I do want to warn you, like I did on the other video, when you have 7/9 as a power on your answer sheet, please write that 7/9 smaller than the x. A lot of people, for some reason, write it like this. What the heck is that? That's like x right next to the fraction 7/9. That doesn't. This has to be smaller, and it has to be up here so it could look like a power to x. So you definitely want to write it smaller above the x, not right next to the x, but above right here. Let's move on to the next even one, 8. Change that rational exponent to a radical. So we did say it's always power. Actually, power over root. Power over root. So what kind of root do we have? We have the third root, and it's x to the 8th power. Should probably do the 8 in blue, stay color coordinated. Do we get that? I've seen students write the third root out here in the front. That's incorrect, right? Whatever root it is, you have to put in between this and this. So it has to be in this area. Whether it's a third root, fourth root. If it's a square root, you don't even have to write anything. Anyway, let's move on. Number 10. So on the other video, I already explained 9. I already explained 11. We're going to number 10 on this video, the even ones. And there's many, many, many different ways of doing this problem. I think the easiest way is to use the negative exponent rule, where if you have a negative exponent, you grab it, move it to the other side, and the exponent becomes positive. Now, in this case, there are no negative exponents, but if I did take this guy and move it up, it will become x to the 3/7, but it's going to be now a negative 3/7, and we are multiplying. Do we understand that? So I moved it up, and whenever you move something from one side to the other, the sign of the exponent changes. That's why this positive 3/7 became negative 3/7. Now, why would I want to do that? Well, because up on top, I have x to the 5/7 times now my x to the negative 3/7, which means I could, rule 1 of exponents, add the exponents, right? When you're multiplying with the same base, you could add the exponents. And that's a great thing because you already have a common denominator of 7. So what's my answer going to be? It's going to be x to the 2/7 power, okay? Now, the other detail that we need to pay attention to is the instructions. A lot of us will put this correct answer, x to the 2/7, and not get full credit. Bless you. Why would you not get full credit? Because it says radical form. This is an exponent, right? This is exponential form. They want radical form. So pay attention to the instructions. Radical form. So what does this answer look like as a radical? What kind of root? 7th root of x to the what power? Second power. It's always power over root. The root is 7, the power is 2. So there's your answer for number, 10. Let's jump to number 12. A lot of students get confused with this one. It's so easy that you get confused, right? How do you solve radical equations? You got to first make sure they're by themselves, and yeah, there is no number out here. It's just a square root equaling a square root. So if it's already isolated, all you got to do is get rid of the radical by applying a power. So whenever you have a square root, how do you get rid of a square root? with the power of 2 by squaring it. If you would have seen a 3 right here, you'd use the power of 3. A 4 right there, use the power of 4. But it's a square root, so you're going to use the power of 2. And of course, what you do to one side, you do to the other side. And most of the time, that involves more math than this, because right here, the square root and the squares completely eliminate themselves, and you end up with g plus 1 equals 2g minus 7. Then it's just an algebra 1 question where you solve by getting g's to one side. And you're going to have 1 equals 1g minus 7. Get rid of that minus 7 by going plus 7, plus 7. You can get your final answer, 8 equals g, or g equals 8. Ta-da. Now, we have an answer. We should double check it just to make sure it's not an extraneous solution. And you don't have to show your work on the double check, but just make sure you do it. When you plug in 8 right here, what's 8 plus 1?
9.
And what's the square to 9?
3.
Okay, cool. So I need this to also equal 3. Plug in an 8 right here. What's 2 times 8?
16.
What's 16 minus 7?
9.
And what is the square to 9?
3.
Also 3. I have double checked in my mind, or in our minds. We just did it. We got the correct answer. We know we're right. Let's move on to the next even number 14. All right. So finally, we have something a little more fun. When you have a radical equation, step 1 is to isolate that radical. Isolate the fourth root right there. So I need to get rid of both the 3 and the 9. I need to get rid of one first. Which one is it? The 9. Get rid of that 9 by going plus 9, canceling it out, plus 9. And let's rewrite this thing. There it is rewritten. And of course, we still need to get rid of that 3 in the front, and that's really a 3 times. So let's get rid of that times 3 by dividing by 3. So we now have the fourth root of 3x plus 6. If you want to keep the parentheses, go ahead, because we're going to have to put it in parentheses anyway, equals 3. And now the question is, how do we get rid of the fourth root? By applying what power? Fourth power. So you do what you do to one side, do to the other. And you now have the simple equation. Wait a minute, I zoomed in too far. Simple equation, 3x plus 6, no more fourth root, no more fourth power, equals 3 to the fourth, which is not 12. It's actually 81. 3 times 3 times 3 times 3 is 81. And let's solve this thing. Subtract 6. You can end up with 3x equaling 75. That's right. Final step will be divide by 3. Divide by 3. X equals 25. That's right, 25. Let's double check our work. Let's plug in 25 right here. 3 times 25 is 75. Plus 6 is 81, right? The fourth root of 81, believe it or not, is 3, right? You could do it on the calculator. You could think 3 times 3 is 9 times 3 is 27 times 3 is 81. So this is really just 3, and 3 times 3 is 9, and 9 minus 9 really is 0. That's the double check. Again, I didn't show my work. I just did it in my head. Moving on to number 16. Let's isolate it. What do I do to isolate it? Oh, wait a minute. Hold the horses here. This is now an inequality, right? Not an equation. Big difference. When you have an inequality, you actually need 2 answers, right? Now, sometimes both answers will work to form a compound inequality. Sometimes only one answer works, so you only get a single inequality answer. But how do we get these 2 answers? One, you just solve it the way you would an equation, and the other is where you make sure that this inside radical value has to be positive, has to be greater than or equal to 0. So you're going to actually get one answer by setting this to be greater than or equal to 0. And you get the other answer by solving the whole thing as if it were a radical equation. So how about this? I'm going to solve the whole thing kind of like if it were a radical equation. And then I'm going to go back and solve x plus 1 being greater than or equal to 0. As a matter of fact, let me just put that right here. X plus 1 has to be greater than or equal to 0. I'll solve that one later. But right now, let's just focus in on isolating the radical by dividing by 4. You will have the square root of x plus 1 is greater than or equal to 3. Keep in mind, guys, that if I were dividing by a negative 4, I'd have to flip the inequality symbol, right? But I'm dividing by a positive 4, I don't have to mess with anything. I do need to get rid of that square root by applying the power of 2 on both sides. So I will get x plus 1 is greater than or equal to 9. And then we get rid of that 1 by subtracting 1. And we'll get x is greater than or equal to 8. So here's one answer. My other answer comes from, again, setting the inside of the radical value to be greater than or equal to 0. Because if it were less than 0, it'd be negative, which means that this would be imaginary, which can't happen. So let's set the inside of the radical value to be greater than or equal to 0, and let's solve. So you subtract 1, x is greater than or equal to -1. So we have both of these answers. How do we determine what's the correct answer? Well, one way is by sketching it on a number line. So we have -1 right here, and we have +8 over here. When we look at the inequality that involves a -1, it says x is greater than or equal to, which is to the right of -1. And when we look at this one right here, x is greater than or equal to 8. That's also to the right. So normally, when the arrows point towards each other, then we would say that the answers overlap right there in between the two values. So if they were pointing towards each other, they would overlap right here. But that's not the case on this one because the arrows are both pointing in the same direction. Okay, the arrows are both pointing in the same direction. So where would the overlap actually be? Anybody? Where would the overlap actually be? On this side of the 8. That's where the overlap would be. Does that make sense? Yeah. Think about this. The -1 is going this way. The 8 is going this way. So the overlap will meet right here, and the overlap is this way. If they were pointing towards each other, yeah, the overlap would be right here, and you'd have a compound inequality as an answer, right? But right now, since they're both going to the right, the overlap is over here on this side of 8. It begins at 8 and it goes this side at 8, which means that the only actual answer is this one, not this one, okay? Now, of course, let's verify that by testing some points. Let me prove it to you that the answers are not in between the two. If I plug in a value like 0, which is clearly between the two values, check out how it doesn't work. 0 plus 1 is 1, the square root of 1 is 1, and 4 times 1 is 4, and 4 is definitely not greater than or equal to 12. You see how 0 did not work? Right? It didn't work. Now, if you plug in any number that's as 8 or greater, it will work. If I plug in, like, let's say 15, which is obviously over here on the highlighted side, 15 plus 1 is 16. The square root of 16 is 4. 4 times 4 is 16. And that's definitely greater than or equal to 12. Any value over here will work. None of these values work if you were to test it. But again, with the sketch and with the arrows, we saw the overlap, and there's our answer, which is only the inequality x is greater than or equal to 8. If for some reason the arrows would have been pointing towards each other, the answer should be in here as a compound inequality. -1 on the left side, 8 on the right side, x in the middle with the less than symbols right there as a compound inequality. I believe on the other examples like 15 and maybe 17, we will have compound inequality answers. So please see the odd video or the odd numbered video to see those other examples. Let's jump to number 18. And I actually explained this one on the other video. So let me go for this one on this video. How do we find the inverse of any equation? This is at the beginning of chapter 6. I hope we remember. Switch x and y. Now, we're not doing any math. We are just magically switching this guy with that guy. Switch them. So we have an x instead of a y, still have the equal sign, still have the 2, and we magically have a y instead of x. So the first part is switching x and y, and then after that you solve for what, Braulio? For y, that's right. So let's get y by itself, divide by 2, cancels, divide by 2, y equals x over 2. This is your inverse function, so your notation could read y to the -1 equals, and you could write this if you want, put a 1 in front of the x. That way you could actually do a 1/2 with the x on the side. There's your inverse function. Y to the -1 equals 1/2 x. If you wanted to, you could leave it as x over 2. That's also an acceptable answer. Okay? So again, to find the inverse, switch x and y and solve for y. If you want to see this example, please watch the other video. Let's jump to 20 and 22. I already explained 21 on the previous video. So on number 20, they want us to plug in our f function into our h function. Again, this is from the beginning of chapter 6. Let's plug in our f function into our h function. So we have 3 functions up there on the instructions, and we need to take our red f function and plug this red f function into the x value of our, let's go blue, h function, okay? So if I'm plugging it into my h function, let's start by writing our h function in blue, but putting parentheses instead of the x. So the h function reads x plus 7. Are you with me? Now what am I going to plug right into this x value? There you go, 3x minus 2. I want to do that in red. And if I had something out here to distribute, I would do so, but there's nothing. There's nothing to distribute. It's a plus 7 at the end, so I don't really even need the parentheses. All I need to do is combine like terms. So I really have is 3x minus 2 plus 7. Final answer will be 3x plus 5. That's the answer for number 20 when you plug in your f function into your h function. The other video will show number 21. I'm jumping to 22. This one, I like these even better than the one we just did. Number 22 is where you actually plug in the number -2 into your g and get an answer, and then plug in that answer into your h and get an answer. So I like it when they actually have numbers. So I think more understandable. So let's take our -2 and plug it into the g function. So what is -2 plugged into that g function where it says -5? What's -2 minus 5? -7. So this guy right here is really -7. So my new problem is really h of -7. So I need to go to my h function and plug in a -7 right there. It's going to say -7 plus 7. -7 plus 7. What's -7 plus 7? Cero. Cerote entero. Did I just say that? Okay. If you don't know Spanish, it's all right. If you do, I'm sorry. Let's move on to the back side. There's a back. Yeah, the final 2 points on this 20 question test tomorrow, the final 2 points will come from, well, actually, there's still three to go through. Let's do the even ones. Right here it says on 24, are the following 2 functions inverse functions? I hope we remember that in order to check if 2 functions are inverses of each other, you need to take one function, the g of x, and plug it inside the f of x, and hopefully you get the answer x. If you don't, it doesn't work, all right? But then likewise, you have to do it the other way around. You take the f function and you plug it into your g function. And both of those have to equal x in order for these to be inverse functions of each other. So if I take my green g function and plug it into my f function right there, let's begin by rewriting this f of x function in red. We have 5x minus 5, and I am plugging in this green one right here into that x value into the parentheses right there. So that's going to be a 1/5 x plus 1. What happens? We distribute 5 times 1/5, that's 5/5, which ends up being just x. And then 5 times 1 is 5. And don't forget about the outside minus 5. And what happens? You do end up with just x. So far we've checked it. It worked right here. We got x as an answer. Let's do it the other way around. Let's take this red function f of x and plug it right into here to the green function where the x is at. So let's begin by rewriting that green function, 1/5 x, let's put parentheses, plus 1, and in those parentheses we're going to put that red function, 5x minus 5. And of course we're going to distribute 1/5 times 5x is 5/5 x, which is just 1x. 1/5 times -5 is a -1. And don't forget about the outside plus 1. So again, the minus 1 and plus 1 do cancel out. And again, we end up with just x. We have verified number 24. What do we say? We say, yes, they are inverse. I can't even spell right now. I'm so excited. Inverse functions. Yeah, I guess a yes or no will work. But if you don't show the work, I can't give you credit. I need to see some type of work that you're actually plugging in one function into the other, and then vice versa. The last 2 points, here it is. The last 2 points of the test come from graphing a, oh, by the way, we're doing I did this one. So let me do this one on this video. I did the other one on the other video. Let's do this one on this video. And I hope we remember that when we graph a radical function, this is from the way back at the beginning of chapter 6, I recommend identifying h and k. H, you think opposite of what you see here. That's -2, which means you're going to be going 2 to the left. And the k value is what you see here, the +9. So the k is +9, which means you're going to be going 9 up. So what I recommend is ignoring h and k, boxing in your function that does not include the h and the k, and then making an input-output table for that boxed-in function. Okay? I'm not going to do the whole thing. I'm only going to focus in on this. So what inputs would be nice when you just deal with the square root? Obviously, perfect square numbers. Like the square root of 0 is great. Why? Because the square root of 0 is 0, and 0 times -3, what do you get? 0. When you plug in a 1, that also works. The square root of 1 is what? And what is 1 times -3? -3. How about when I plug in, what's another number to plug in? A nice one? 4. All right. So plug in a 4. The square root of 4 is 2. 2 times -3 is -6. And then what's another nice perfect square number? 9. If I plug in 9 right there, the square root of 9 is 3, and 3 times -3 is -9. And of course I could keep going because this does go forever, but these are the coordinates, good enough coordinates to graph my equation without the h and k. So I'm not really going to graph it, I'm just going to plot the points. 0, 0, 1, -1, 2, 3, 4, 1, 2, 3, 4, 6. Okay, sorry about that. I had to zoom in a bit to get those right coordinates. However, I'm not going to draw it. Why not? Because these coordinates belong to the function without the h and k, and we know we really want to graph the function with h and k. So h and k are your shifts. So you need to move all these coordinates 2 to the left and 9 up. So every single one of these need to move. Let me zoom in on this so I don't make mistakes when I move them. I want to go 2 to the left and 9 up and put a dot right there. I want to put the dots in blue. And if you move the next one 2 to the left and 9 up, you'll end up right there. If I take the next one 2 to the left and 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. Did I do that right? I hope I did. And the last one, 2 to the left, 9 up is right there. So how does this graph go? It begins at your hk value. What's our hk value? -2, +9. That's the beginning point. -2 on the x, +9 on the y. That's right here. And it's going in this direction. So the beginning point is right here. Now, this hk value is important because that's where those are the values you're going to utilize to state the domain and range. So this graph, not the original dots, but the shifted graph, the one with the final product including h and k, does it exist at -10?
No.
No, it starts here and it goes that way, right? It goes in this direction. So the domain values are your x values. So what do we say the domain is? X is, and you're going to use this x value of your beginning point. X is less than -2 or greater than or equal to -2? Greater than or equal to -2. Why is that? Because here's the x value of -2, and on your x's, do you go to the left to show the graph or to the right? This graph is going to the right, which means greater than or equal to. The range are your y values. And all of your y values are at the value of 9 or below. They're at this height of y is 9 or below. So what's our range? Y is less than or equal to +9. Ladies and gentlemen, we are done. Actually, I'm done. You're not. You still need to go back and do all the odd ones. And if you need help on those, I could help you right now in class or from home. You could watch the other video, which explains the odd questions. Once again, the test is only 20 questions long. Each one of these, I'm deleting like almost half of the test. Okay? Actually, a third of the test to be more exact. Good luck. Study.